Welcome you all for the next tutorial. It is about the cell sorting. So the name is different, right? So compared to other sorting techniques, this shell sort is somewhat different, and you have to understand, you have to listen carefully so that you can able to understand. It is also an in-place comparison sort, since it needs only n element space, not more than that. Okay, so not extra space, no more extra space is needed to do this sorting technique, to perform this sorting technique. And it is a variation of sorting. I already told you, right, about compared to bubble sort or insertion sort or selection sort, it is a variation of sorting. Okay, so bubble sort, it will do sorting by exchange. Okay, and insertion sort, it is sorting by insertion, and selection sort, it selects or it picks the minimum element and then places in order. Okay, sorting by picking, sorting by selection, and here it is a variation. Then what it does, what this cell sort does, it allows exchange, okay, but of far items fast. It allows exchange of far items. So bubble sort, it compares element with the adjacent element. Okay, and in the insertion sort, the picked element is compared with all the elements in the sorted list on the left hand side. Again, adjacent elements and or compared. Okay, and in the selection sort also we are comparing the element in some order. Here it allows exchange or it allows comparison of far items. Okay, so far items faster at a particular gap. Okay, it leaves some gap and it takes the element from the far off position and it compares. Okay, in that way we can sort the elements, or we can exchange. Sometimes we'll see the example. I'll show you the example so that you will understand. See, in this list we are having smaller numbers like 2 and 7, or at the end of the list. Okay, so when we are using bubble sort or insertion or selection, it is very hard to move these items to the first position, to the initial position. Okay, so if the list contains elements, smaller elements at the farthest position, means we can go for cell sorting technique. Okay, so it allows exchange of far items faster. Okay, so far smaller items faster because it compares element at a particular gap or particular interval. Okay, so it is more efficient. This algorithm is more efficient when, okay, it is compared to insertion and bubble sort. We can say it is efficient when in some cases this algorithm works better. Okay, it gives a good result. Okay, the cases smaller value elements or towards the end. If the minimum elements or very smaller elements present at the end of the list. Okay, so in that case this algorithm is more efficient compared to insertion and bubble sort, and it works well for the large sized array or for the large sized list also. Okay, but when we discussed about insertion selection sort, right, in the last tutorial. So insertion and selection sorting technique, it is applicable for the smaller sized array, only for the small set. If the set is small, if the list number of elements in the list is small, so that works effectively. Okay, we'll get good results. But here this shell sorting techniques, it works for the large sized array also. And here the efficiency, it depends on the gap or interval selection. So based on the gap or interval selection, so the efficiency is decided, and the time complexity of the algorithm is also order of n squared. Okay, and this cell sorting algorithm have different time complexity in worst case, best case and average case. Okay, so we'll take only worst case complexity. The worst case complexity is order of n squared. Okay, right, we'll see the algorithm steps and we'll see the example. So take input array and size of the array and gap as n. Initially you have to set the gap as n. Okay, so gap value as n. Okay, so before comparison, before starting your algorithm, so then after that, in the second step, you have to calculate the gap value. You can hear the gap calculation formula is gap by 2. So initialize the value of gap interval as gap by 2. Okay, so here it is wrongly typed. Okay, gap by 2. So you can take gap by 3, gap by 4. So the efficiency depends on this value. Okay, so here for my example I have taken gap by 2. So gap by 2 iteratively. The first time it is gap is equal to gap by 2. For example, n is 9. 9 by 2 it is 4. Next time what will be the gap? So last time gap is 4, upon 4 by 2 it is 2. Next time gap value will be 1. So likewise iteratively the gap value changes and accordingly it compares the element. So after initializing the gap value, so you have to compare those two elements at a distance of gap. Appo first element gap kapra irukra element we are going to compare. Okay, and second element, and after a gap, after an interval, we are going to take another element and we are going to compare in each and every iteration. Okay, and if the element at the left is greater, okay, the left side element is greater than the element at the right, means we are going to perform a swap or shift. That's the user's choice. They can implement either bubble sort or insertion sort. Bubble sort means it swaps the element. Insertion sort, it shifts and insert the element in the position. You can use either swapping or shifting mechanism, okay, in order to exchange these two elements, and repeat these steps until the gap becomes 0. If the gap becomes 0, you can stop performing the algorithm. Algorithmic steps will get the sorted list. Okay, right. So now we are going to see the example with algorithmic steps. Okay, this is the explanation. In the next slide we'll see the detailed steps. So initially you are having a list of items. So here we are having 9 elements in the list. Okay, and here you can see smaller elements. Okay, smaller elements are at the end of the list, so you can go for shell sorting technique. Okay, so here n is 9, so gap is also 9. So before starting your process, you have to find out the gap. So here we have used the formula gap is equal to gap by 2. So gap value is 9, so 9 by 2 it is 4. So usually we'll consider only the integer value. Okay, so 4, gap value is 4 initially. Okay, with that gap you have to compare the elements. Okay, then pass to gap is equal to gap by 2. So gap is 4, so 4 by 2 it becomes 2. And in pass 3, gap is equal to gap by 2. So gap value in the previous pass is 2. So 2 by 2 it is 1. Okay, then in pass 4, so gap value in the previous step is 1. So 1 divided by 2 it is 0. So we can stop here. Okay, algorithm ends. So now we are going to see the example. So see here we are having the list of elements. So initially n is 9 and we are initializing the gap with the formula n by 2. Okay, so 9 by 2 it is 4. Okay, we are not considering the floating part, okay, the decimal part. We have considered only the integer part. Okay, we are doing integer division. So the gap value is 4. Okay, so the compare two elements at a distance of gap. Here the gap distance is 4. Up 4 gap we are going to compare. Here I have marked in different colors. Which two elements will be compared. Okay, 0th element is compared with 4th element. Okay, 4 gaps, 1 2 and 3 4, 4th element. Okay, and first element is compared with 5th element, and second element is compared with 6th element, and third element is compared with 7th element, and 4th element is compared with 8th element. That's all. Okay, when you consider 5th element, so 3 gap da irukku, so no more element after 8, so we have to stop here. Okay, 4 and 8. So here A of 0 and A of 4 will be compared first. So what is the element in A of 0? It is 170. 170 is compared with 66. So 170 is greater than. So the left side element is greater than the right side element. Usually, for example, in our array, if you are having indexes like -1, -2, -3 and -4 means, so you have to do the left side, consider the left side gap also. A of 0 edoda compare pannom, A of 0 is compared with A of 4, as well as A of 0 is compared with A of -4. So here we are having only positive index, so we have considered only 0th and 4th element. So you have to check the left side as well as the right side gap. Okay, so both gaps you have to consider. Okay, so here no elements in the left side, so we are considering only the right side gap. Okay, right side interval. So 170 and 66 will be compared. So 170 left hand side element is greater, so you need to swap. So edala swap aayirukku 66 and which elements? 170. 170 is swapped here. Okay, then the next step, so A of 1 and A of 5 compared. Okay, in A of 1 position 75 and 2 both are compared, it is greater, so swap. Likewise it goes on. Okay, so A of 4 and A of 8 will be compared. Okay, what element in A of 4? It is 66. Okay, 60, sorry, you have to consider the previous list. Okay, in this list, A of 4 you are having 170. Okay, so 170 and the A of 8 element is 7. So you have to consider these two elements, 170 and 7. The left hand side element is greater than the right hand side element, so you have to swap. Okay, so when you done this swap, okay, so either change pannirkonama, we have changed, we have swapped this 8th position element to 4th position element. Okay, once this swap done, you have to compare this element again with the gap before that, because already we have done the comparison. Now we have changed, we have checked with another number and we have changed the number, exchange aayirukku, vera oru number vandirukku, appo again we have to compare with the first element. Appo see here, so after this swap we are having like this 170 inga vandrum, inga enna number vandirukku 7 vandirchi, again you have to compare 7 and 66. Okay, so 66 is greater, so again it needs swap. Okay, so 7, 2, 24, 45, 66, 75, 802, 90 and 170. So this is about the list after pass 1 with a gap of 4. Okay, and the next pass you have to consider the gap again. You have to calculate the gap again, initialize the gap again. So gap is gap by 2. So in the last pass gap is 4. So 4 by 2. So now the new interval is 2. Okay, so we have to compare like this: A of 0 and 2, A of 1 and 3, A of 2 and 4, A of 3 and 5, A of 4 and 6, and A of 5 and 7 and 6 and 8. Likewise you have to compare. For all these things no swap is needed, because in the first pass itself smaller elements are moved to the initial positions. Okay, so this is the advantage of cell sort. Okay, so in the last step, okay, A of 6 is compared with A of 8. Okay, 802 is compared with 170, so the left hand side element is greater, so swapping is needed. Okay, once you done the swap பண்ணதுக்கு அப்புறம் என்ன செய்யணும்? You have to consider the previous gap. இன்னொரு gap check பண்ணனும்ல, check பண்ணி பார்க்கும்போது no swap is required. So that's all about pass 2. After pass 2 you are having the list of elements. Okay, then in pass 3 you have to initialize the gap again. gap is equal to, in the previous pass gap value is 2, so 2 by 2, the formula is gap by 2, so 2 by 2 it is 1. So in pass 3 adjacent elements are compared like bubble sort mari adjacent element compare panu. 7 and 2 are compared, 2 and 24 are compared, 24 and 45 are compared, 45 and 66 are compared, and 66 and 75, 75 and 170, 170 and 90, 90 and 802. Okay, so after doing these comparisons we'll get the list. Okay, so once the swapping is done, என்ன பண்ணனும், previous check பண்ணனும். You can see the last step, 170 and 90, 170 and 90 are compared. Okay, swapping is needed. 170 விட 90 தான் smaller, so you have to swap. Okay, so once you done the swap, திரும்ப என்ன செய்யணும், back side check பண்ணனும். Here adjacent elements are checked, so அதனால ஒரு changes இருக்காது. Then 90 and 802 are compared, so no need to do swapping. So then in next pass you have to initialize the gap value. So here the gap value is 1, so when you do 1 by 2, so your gap value becomes 0. So your when the gap value reaches 0, you can stop performing the sorting technique. So we reach the end. Okay, you can see the list. So our list is sorted after completing 3 passes. This is about the cell sorting technique. So here exercise is given. So sort the list of numbers using shell sort. Okay, so here shell sort is nothing but with the interval the elements are compared. Okay, so it depends upon efficiency, depends upon the gap value. You can use any such a formula to calculate gap. So here I have used a simple formula, gap is equal to gap by 2 iteratively. For each and every pass you have to repeat the same calculation. You can use your own formula to sort the elements with the help of shell sorting technique. Thank you for watching.